nice because Eric wanted to play guitar and he got a nice big crowd. It was really nice of you guys. So we're going to do a problem that looks like the guitar problem, but is a bit cooler. At the same time, there are fewer states, so I think it's easier to manage. How many people know how to play DDR?
Well,
Yeah. OK, how many people know the rules of playing DDR? Because otherwise I wouldn't be able to lift my hand up. OK. OK, so let's go through an algorithmic model. So you have a board that basically looks like this. And you have 4 touch-sensitive pads, up, down, left, right. And then you have a center position. You also have a sheet of notes that looks something like this. Say up, up, down, down, up, down, up, up, down, left, right, left, left, right, right, so on and so forth. So when you see an arrow of up, that's a constraint that says one of your feet has to be on the up arrow. Has to tap the up arrow, actually. There's no constraint for the other foot. So your other foot can be anywhere else on the board. It doesn't matter. You're also allowed to tap the board some extra times. So if you don't have a note showing up, you can still hit the board and there's no penalty. So you can hop around as many times as you want, or as many times as you can until you run out of breath. So up basically means it's actually up. One foot has to be up, the other one center. Also, of course, because of the design of the board, it doesn't matter what foot is where. So what are possible goals for this game?
that's good enough.
OK.
So hit all the arrows when they line up with the top row.
OK, so there are 2 different ways of doing it. One, you said not to get an F. So I would say, given some limited set of skills, so given a set of skills or your skill level, maximize your score, right?
Yeah.
This is dynamic programming, so we always want to maximize something. Now, if you're really good, then another possible goal is hit all the notes with the minimum amount of effort. If you're going to be in a competition and you're going to be doing 10 songs, you don't want to die after the first song, right? So assuming you can do everything reasonably well, this is another possible goal. Any other goals? So we're brainstorming here. This isn't set in stone. We've already seen a formal solution for this problem, so I want to play with it for a little bit, right? We brought a DDR pad, so I want to play with it. What else could you hope to maximize or minimize for with dynamic programming?
Not look ridiculous. Like, I mean,
Okay.
sure, there's some I guess we're looking at the cost of each move, right?
So hit all the notes, minimum effort, or otherwise, say,
Silly.
best appearance. So every move looks somewhat good or somewhat bad, and you want to do the moves that look as good as possible. So this maximizes entertainment, right? If you're on TV, you probably want this. Now suppose you're in a competition and you only have 1 track to play.
Well, then you know where all the notes are.
Sure, like we assume that we know this ahead of time. So you've memorized this and you're trying to compute the best strategy so you can memorize that. And when you go and play, you dominate.
Yeah.
So if you have 1 track, then I would say that what you'd want to do is minimize your probability of failure. Right? So given the probability of failure for each possible move, you want to minimize the overall probability of failure so your teammates won't hate you. So hit all the nodes and minimize So this one's a little bit different for the other ones because all the other ones are already set up as a nice problem where you add up things. So you can solve them with graphs or with dynamic programming. If you want to minimize the probability of failure, then you want to maximize the probability of success. The probability of succeeding on all your moves is the product of the probability of succeeding on each move. All right, so if you have 5 moves and you have 5 individual probabilities, you multiply them up, and that's the probability that you'll execute the whole sequence correctly and not stumble. So we have products instead of sums. Yes?
Isn't it related to the maximizing score goal?
You can, well, not necessarily, because this one says that you only have some possible moves. I think in the end, all of them, except for this last one, can be solved using the recursion that we have. For the last one, you have to do a bit of massaging, and we're going over that right now. So you have products instead of sums. How do you turn products into sums? Yep. So for this one, I would want to use logs so that I can say that I want to maximize the log probability of success, which is just the sum of the log probabilities for each move. And then it looks like dynamic programming as usual. Now, if I wouldn't want to use logs, if I'm using the DP formulation where I'm doing recursion, I can incorporate products there. But it turns out that in practice, if you have a lot of numbers that are close to 1 or that are close to 0, so all the easy moves are going to be really close to 1, for example. If you have a lot of moves, numbers that are close to 1 or close to 0, if you multiply them up, you'll get numerical instability. So you get a number that's really close to 1. So for example, if I'm choosing whether to do, say I'm here and I'm thinking, do I want to move like this, or do I want to move like this and then like this? These are both pretty easy moves. So in both cases, we're looking at probabilities of success of 99.991 and maybe 99.992%. So if you have numbers with probabilities that are really close to 1, and if you have a lot of them and you try to multiply them, you're going to get bad results. So all the products are going to start looking the same. So you're going to get a random solution instead of what you want. This is a practical thing. It's called numerical instability, and it's a practical reason why you'd want to use logs instead of multiplying things up. So it's not just a theoretical thing. It also makes life nice in practice. OK, so we have a goal that looks like this. Say, let's go for this one. Hit all the nodes, minimize the effort. And all the other ones can be reduced to this one. We need to define effort, right? Let's say that we have a function called delta that takes 2 foot locations, so where both of my feet are, a from and a to, and it gives me a number from 0 to 1, where 0 is really easy and 1 is really hard. So from would look something like my left foot is up, my right foot is centered. 2 would look something like my left foot is centered and my right foot is up. So basically going from here to here. So from left foot up, right foot center to here. So there's some difficulty there, right? I had to jump, so it's not 0. I'm burning some calories here. So any move that I make has some difficulty, and I want to solve the game so that overall I have reasonably small total difficulty. OK, are we understanding the problem? So we have 3 possible avenues here. We can start solving it using dynamic programming. We can start solving it using graphs. Or we can have someone else play the DDR again so that we can get more hands-on experience and look at what a good strategy or a bad strategy looks like. So you guys get to vote. Who wants to solve this using dynamic programming? Who wants to solve this using graphs? Who wants to get more hands-on experience? Damn. I was hoping the DDR would win. You guys are boring. So graphs, right? We're going to have nodes. Nodes represent states, right? So a state is where you are at some point in the game. And we'll have to define what that where you are means. And then when you jump, you make a move. So moves go between states. So in any game, you have states and moves. A state is where you are at a point in time, and then you make a move. Like in chess, your state is your board position and whether you're moving or your opponent is next to move. And the move is when you take a piece and put it from one place to another. So your vertices are states, and your edges are moves. So what's in a state? This is the hard problem. Whether we're solving it with graphs or with dynamic programming, this is what everything comes down to. What's in a state?
For some of the difficulties, yeah, so your current state is how much difficulty have you, I guess the probability, are those representing the probabilities, the difficulties, or?
So this is the difficulty for one move. Does it depend on previous moves?
No, but.
No. So it's a nice thing to note that the difficulties for each move are independent.
Wouldn't it be dependent in real life? Because he'll get tired at the end and he's able to have less energy too.
Yep. So in real life, we might want to say that this actually depends on how much energy you've expended so far. And if we have time, let's solve that problem. So the nice thing about this problem is there are many directions in which we can take it. This is one of them. I'm fine, and I think we'll learn a lot by doing that. So back to the original problem. Suppose that it doesn't matter how tired you are. You're pretty good, so you're not going to be tired enough to be like... So mostly independent difficulties for each move. What's in a state?
The sum of the difficulties up to that point.
Okay, so...
I guess the sum of the appearance factor, if we're including that, or are we only doing?
So we're doing this.
Effort.
Yeah.
Okay, we're minimizing effort.
So the way I like to think of this is, what does a solution look like? It's made up of decisions, right? What are the decisions?
Make that move or don't make that move.
We'll see. But once you know what the decisions are, then you have to think, what do I need to make a decision? So a note is one of these. For some reason, they're called notes.
So you know that somehow your path has to hit all of them. Like you can have steps in between.
Yep.
Like moves in between, but you have to hit all of them.
Okay, so I like this. So every one of these is going to have to generate a move. And there might be some moves in between. Well, each move is going to map to some edge, and I'm going to need vertices. So as an algorithms programmer, when I hear that, oh, I can have some moves in between, I get really uneasy. Like, oh, what is this? How many moves am I going to have? Is this going to become really huge, and am I not going to be able to run any algorithm on it? So let's think about that. How many moves would I have in between, and what would I achieve with them?
I guess you'd have a max of like 4, right? Well, I mean, you can put your right leg someplace, you can put your left leg someplace. That's like a max of 2, right? Or no?
So let's think of an example. You want to go, say, I want to go what, from here to here, right?
Mm-hmm.
And you're thinking what, I can do this, oh sorry, so I can do this as one move and this as one move.
Yeah, or you can just do one jump, right? So it's,
Yeah.
I guess that's more
Okay, so looking at this, if I'm considering whether to go from here to here, if I want to go either this way or if I want to go this way, so let's write this down on the board. So I'm going from up, down to left, right. And I'm considering, do I want to go directly or do I want to go up, right first and then left, right. Let's not do these arrows because they're confusing. So do I want to transition like this or do I want to transition like this? Well, I claim that since my moves are independent, if going from here to here, if it's beneficial to go this way instead of this way, I would want to go this way all the time. So I would just say that, look, inside my delta here, I would say that actually, if you know what you're doing, whenever you have to go from here to here, you're going to go like this. And the delta is going to report the total delta for this. So if the problem is that I have one note, and then I have my next note like this, between these two nodes, I can always go in one move.
So you're saying, well, like, including in our difficulty function, it'll also tell us like what move we should make to get there?
How to get there, the best way to get from one state to another.
Okay.
Well, like when you're learning DDR, these are the basic steps, right? Like you practice until you know how to get from one place to another. There is something else where you need intermediate steps.
Or if you're holding one and then you gotta move to another, right? Oh, maybe not.
So let's not worry about holds. Let's say that we'll just represent holds as so if you have a hold in a game, then we're just going to represent it like this. We're going to cheat. So we don't have to deal with it. In real life, you would have to deal with it, like if you're actually writing a program that trains people.
What was if you have like up, right, left, up or something? So you'd have to, like, let's say you start off hitting your right foot on the top, and then you have to hit the left, or no, they have to hit the right one again. And then you have to hit up again, and then you have to transfer. So I guess you have to go through, any time you have to go through the middle. Like to move your foot or something.
So I like the idea of going through the middle. Why or why would you go through the middle?
So you avoid crossing your leg over or something.
Well, what if I have something like this? If there are DDR experts, I know this isn't the right way to do it, but one way of doing it is left, right, left, right, left, right. So then I have some states that account for the fact that I'm centering. So some people like to do this, right? Some people like to go to the center as much as possible if they have time between the moves. So then I would need at least one state in between where I'm allowed to center. Right? In order to represent what I just did there, I need one move. Because I'm not going to go... So one way I could meet this is I have left center, and then left right, and then left right, left right, left right, so on and so forth. But this would mean that instead of doing this, which is reasonably easy, I would have to do this, and then jump, 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 jump every time, harder. Not good. Not good for my knees, not good for my score. So I don't want to do this. I want to have intermediate states so I can say I start here, and then I get back here. Then I do this, then I get back here. Then I go here, and then I go back. Here, and then go back. Do you guys see how this works?
You can also rock back and forth too, so that would require both feet not to be on the ground the entire time.
Rock back and forth. Hold that thought. That might come in handy, assuming we have enough time. So if we only do one move every time we see a note, we're stuck with this. in order to allow recentering, we have to add states between the nodes. And we need to add one intermediary state. And you can either think about it or take my word for it, but if you represent the nodes using the trick that I said above, and you want to represent centering, then all you need is one extra state. So one extra move between every two states. Between two nodes. And that's enough, because that one extra state allows you to recenter, and it allows you to do pretty much everything a beginner like me would know how to do.
So you only need one extra state between each move, not like.
Yep. That is the insight. That is where I'm thinking, right? So I had to do both this trick to see that I don't need an infinite number of steps, and come up with the need for centering to see why I need one intermediate step. By the way, does anyone know what's the right way of doing that? What's the right way of doing this move? You said rock back and forth, so I wouldn't rock back and forth in this case, right? Because that wouldn't be helpful. How would I rock?
I mean, like you hold on one and then you go to the other one.
Yeah, so rock left and right.
That's what I meant. That's what I meant.
Okay.
Oh, I said back and forth. I meant.
Sorry, I thought back, forth. So the optimal way of doing this is left, right, left, right, left, right. So what am I doing?
You have like another
It's
move.
kind of like hitting both of them.
Oh no, you have like you have like a 1 foot like you have
Well-
a state for your foot where it's not touching the ground.
Okay, so it's an interesting and important distinction. So if I wanted to hit both of them, if I'm here and I need to hit both of them, I need to hit them.
Okay.
If I only need to hit one of them, if I'm here, I can hit it like this. If I'm here though and I want to hit it, I have to lift myself up. So the difference is whether I'm like this or like this. Where's my weight?
I see.
So if I want to allow for these moves, if I want to go past the stage of very beginner, aside from keeping track of where my feet are, I have to keep track of whether my weight is on my left foot or on my right foot. So I would actually have L, R, and W, where W is either L or R.
So your state now has what foot you're currently putting more weight on.
And where each of the feet is.
Yeah.
Yep.
Where each of the feet are,
R.
and then also the and the sum of the difficulties. So that's all everything in your state, right?
Oh yeah, so I didn't think of, I was just talking about foot position, but we need to get back to the state thing soon. That's a good point. So before we get to that, how many foot positions do we have? If we don't include the weight, where do I have my weight? How many possible positions for both of my feet do I have? So I have 2 feet. Each of them can be in any of these 5 squares, right? So how many total positions?
5 choose 2. Right, you're choosing 2.
So I can do this.
Sure, why not?
Well, if I have 5 choose 2, then
Oh,
you,
that doesn't quite work.
yeah.
Yeah, no.
So, flip. Yeah. So you have 2 feet. Each foot, 5 possibilities.
Yeah. Oh.
Now, what if we have weights? If we are tracking on where I keep my weight, how many possible positions?
353. Oh no, because there's only 2.
So,
So,
for each of these, there's 2 possibilities now. So 50.
You also have the case where your weight is like
In the middle?
yeah.
You can. Based on what I've been reading, you never want to, because if your weight is in the middle, then you're extending a lot of effort to move your either foot. So you always want to have your weight somewhere so that at least for one of your feet, it's really easy to move it.
Could it be either forward or back?
If that's not true, then yeah, I would need to have a center. Oh, so like whether I'm like this or like this?
Yeah, if you're like doing the same thing, rocking back and forth.
So if I have 2 feet, then this says my weight is on my left foot, my weight is on my right foot.
Okay.
So L and R is which foot, not where on the board.
So did you not do center because it was optimal? Or?
Because I claim that in an optimal strategy you wouldn't have it. But you don't have to take my word for it. If you don't believe me, then you add center and you just have more possibilities. And if it happens to not be an optimal thing, then the dynamic programming will ignore it. So how many positions do I have if I add center? So if I have left, center, right for each position. Cool. Yes?
So why do you have 25? Like you wouldn't actually have both of your feet 25.
Why?
I have that as
Maybe, well, especially if we're maximizing this one, actually. Especially if we're maximizing entertainment, then it's definitely cooler to do this, right? You get the point.
possible way, like combinations of like where you can have your feet at one time. Like not necessarily what the game is asking you to do.
Yeah, so this is where my feet are. This is, like the game will always ask something like this. So the game won't always care about both of my feet. Sometimes it will only care about one foot. So yeah, there are two different concepts, right? There's the position of my feet, and then there's the note on the screen. And my feet have to match the note on the screen, and we'll have to capture that somehow. So what's in a state? What are my decisions? Come on, now we should be in a good shape to know what my decisions are. What do I decide every time?
What moves to make?
Yeah, how am I going to jump, right? Where my feet are going to be in the new position. So every time I'm deciding what's the new foot position.
Aren't you also deciding the weight position? Where you're going to hold your weight?
Okay, so when I say foot position, it's a cheat word for everything. So yeah, good observation. Okay. What do I need to know in order to make this decision? Okay, there's also, I would need to know where I was before if I want to compute the difficulties. But aside from that, what?
Sorry, it came with this polynomial.
All right.
Is that a hint to what the runtime of this will be?
It's not on purpose, but yes. So, that makes sense. Polynomial, good. I should probably not have my screen up without me looking at it. Okay, so back to decisions. I think I want to know what's going to be on the screen when I land, right? Because if the screen says, yo, you need to go up and down, then maybe I shouldn't do this, right? That would not be good. So I need to know what the note is going to be when I land. Note.
Not the same as the next.
Yep, next note.
move.
Yeah. So the next note here on the screen. So my position in this list, basically.
Okay. So it's kind of like the knapsack problem where it's like which thing we're considering picking up. But in this case, it's coming next.
So it's close to knapsack. But the difference is in knapsack, I have to decide, do I choose this or do I ignore it? So if I'd be like, I want to maximize my score, then like if I can only do a few things and I want to maximize my score, then maybe I would choose, all right, this is easy, I'm going to do it. This is hard, screw it. This is easy, I'm going to do it. So then my decisions are 0, 1,
Right.
pick or not pick.
Okay.
In this case, every time my decision is a new state of my feet. So it's not 0, 1.
Okay.
That's the difference. And then because of that, the state is going to look different and the recursion is going to look a bit different. Okay, so I want to know the node that I'm landing at. I want to know the sum of, well, we'll see if I want to know the sum of difficulties up to this point. And I want to know one more thing. So if this is going to be my new state, and I know what node I'm landing at, I'm making a decision. The decision tells me where my feet are going to be. Right? The move decides where my feet are going to be. What do I need to do? What else do I need to know my total solution? So what do I need to know to consider between decisions? So say I'm considering the state of, I'm at node 2. Node 2 says left, right, and I'm considering of coming here from node 1, where my foot position was up, down, or come here from node 1, where my foot position was left, right. I need to know where my foot position was to choose between these, right? If I don't know that, then I can't choose.
Was not part of your state though?
Not yet.
Oh.
It's not here, so it's not part of my state. We've been talking about it a lot, but we didn't put it here. So let's say that the state is going to have the node that I'm landing at and my foot position after landing. So if I know that I'm going to land like this, then I know where I was here, LR, say LR. I can compute the costs here, right? This is delta of going from this to this. And this is the delta for going from this to this. Do you guys see? Is that too small? So when delta wants to know where my feet were before and where they're going to be now. So when I call it, I need to know where I was before, and I need to know where I'm going to be now. So this should be part of my state. So a decision says, what's my new position going to be? So when I make a move, I influence my new foot position. They're going to be in some place. And independently of that, the position here, the position of the node increases all the time, right? Because time can only go forward. How are we going to account for these extra moves?
Wait, which extra moves?
So we said that between every two nodes, we might want to make one extra move.
Can you just put like a potential new node in between your current node and your destination node? Yep. And then just fill in the difficulties for that and see which one is smaller.
So if I want to use the algorithm that I already have, that compares my landing position to my node to see whether I can go there or not, what node would I want to put in that intermediate node? So you're basically saying between every two nodes,
yeah.
I'm going to have one more node. And my feet can be wherever here.
Oh, I mean, you also have the edge originally connecting them. So you'd have it going to the intermediate node, but also from the destination. Yeah, like that. But then you'd have to kind of...
So what node would I have here?
I mean, it's good at the center. Right?
Do I have to be at the center?
I mean, it could be anything.
Yeah. So I'm going to invent a blank node.
Mm-hmm.
That's a big O. That means you can do whatever you want. There are no constraints. So that's just an intermediary state. So then I'm going to take this input, and I'm going to add these blank nodes here. And these map to adding nodes in the graph.
Well, then when you just run through your difficulty function between each two nodes and see if, for all the potential moves, which one minimizes that path.
Yep. So basically, I'm assuming I don't need this. I'm assuming that this is going to be, there's at least one choice where this is going to have the same cost as a direct move. And then I'm going to say that instead of having more complex shapes in the graph, I'm going to insert extra moves here.
Okay, I would think that if you have an intermediate move, it might be, less expensive to just hop to that new position than to have an intermediate move, right?
Yeah, then I'm going to assume that either that's not the case or that I can always find an intermediate move that makes my life better.
Every case.
Yeah.
So
This turns out to work. You'll have to take my word for it that this works, and this makes your dynamic programming easy, and it makes your graph building easy. So the advantage of this is you're changing the input. And then when you're building your graph or when you're doing the DP, you only worry about an input that looks like this. You don't care about any intermediate stuff. You have nodes and you have to transition between the nodes, period. So we've reduced the complexity of the problem. So whenever you can get away with that, it's really nice. We can do that for centering. We might not be able to do it for other more complicated stuff. Okay. So we sort of know what we want in a state. Now we want to build a graph so that the path from some source to some destination has a cost that's equivalent to the sum of these difficulties. Right? Because then I can run shortest path and my solution will be right there. By the way, you guys seem awfully sad. Do you want to take a break and play for a little bit more? Yes? How many people want to play instead of... You don't have to play yourself. You can just rest for these 2 or 3 minutes. And you can watch someone else play and get more intuition about how you're supposed to play. Okay, so one person wants to take a break. Everyone else wants to keep going? Or you guys passed out already? So, sort of. Yeah, you'll get out 3 minutes earlier if we don't do DP. Sorry, if you don't do another round. So who wants to keep going?
No, it's play.
Okay, so who wants to keep going? You can only vote one thing. Who wants to play?
Victor, go.
Okay. Who wants to go? Okay. I can go 2 at the end.
If you run the algorithm in your head, you can minimize your effort.
Wait, what? Why is this going? Did you make it go again?
No, I think
Okay.
you made it go again. No, I'm serious.
Yeah. Blame it on the TA. Okay. Yeah, we'll go with the same song. So you'll see the nodes coming from the bottom to the top. When they hit the top, you have to hit. Yeah.
Why is this hard?
Is it hard?
Oh, God.
Oh shit, it's harder. Never mind. Let me reset it. This is not good.
Can you play on hard, Victor?
I can get a deal on easy. Hey, I started last night.
Wait, on anything or just on this one song?
I haven't tried many other songs.
You're still going too hard. Or at least
There you go. I don't know why it's on hard by default.
I locked it right before. Alright.
All right, have fun. So look at the strategy and see if there's any other optimization we can make.
He's using the intermediate nodes there.
Nice.
Just finally it.
So see there he's using the fact that you're not penalized for extra bits. So if he misses one, he's just doing it again. And that's the right thing to do.
I think that was meant to be simultaneous.
It's still loud.
Does anybody play Flash Resolution? It's with a keyboard. It goes much faster.
Wait, it's with a keyboard?
Yeah.
You just
Like keyboard?
Yeah, just like the arrow keys on the keyboard.
Oh, so you like to type?
Yes.
Okay. Yeah,
No,
I
I
don't know.
play Stepmania on a keyboard. They're pretty ridiculous.
Yeah, it goes
Like-
really fast.
Real fast.
Well, so the thing is, I don't know if this is as fun with a keyboard, but you know how we're solving StarCraft? Now that we know dynamic programming, we can solve StarCraft with dynamic programming, and we can account for where your hands are on the keyboard and try to minimize the...
Oh my god!
So this will improve your micro, right? You learn how to do moves.
What hockey you had like doing that?
Yep.
At least they're all on a strong beat. Nice.
If you also make for Guitar Hero, that'd be a cool UAP project. Did you learn anything?
I think I failed this one. Pretty sure I failed this one.
Okay, so it's hard, right?
Yeah.
So we need optimizations so that we can play better. Okay, I think I can get a D with a slightly more optimized solution.
Go.
I will do that after class, so you have an incentive to pay attention until then. So we decided what we're going to have in nodes. And we're going to build a graph where the nodes are the states and the edges are the moves, right? So a node tells me, just like there, what node I'm at. Say I'm at node 2, and where my feet are on. So left foot left, right foot right. So given a state, what outgoing edges do I build? Where can I go to? So let's say I have a state that says I'm at node n, and my left foot is in some position, my right foot is in some position. What are my outgoing edges from here?
Is there an outgoing edge to every move? Because there's a blank.
Okay, so well, actually the blank is a node, right? So you can have, if the next node, if node 3 is a blank, then the node is a blank, and then I can have...
But I guess, isn't the difficulty of the move dependent on what note that blank actually is?
So it doesn't depend on what the screen says, it depends on where my feet are.
Oh, okay, I see.
So I have a number that tells me what's on my screen.
Right.
This number is enough for me to know what's going to be on my screen from now on until forever, because I have the list ahead of time.
I see.
And then I have the position of my feet. So these are both part of the state. So I have nodes for all the nodes and all the positions of the feet.
Right. But the blank note is just one position of the feet?
No.
It's all positions?
Yeah.
Because isn't the difficulty dependent on what position your feet end up?
Yeah, so it's from where I start to where I land. So if I decide to start, from here and go here,
Yeah.
the difficulty of this move is so it doesn't depend on whether I have a blank there
Right.
and this was okay, or if I had an up down, then I just missed a note.
Okay.
But the difficulty, the effort I'm expending is the same.
Okay. But if you start from that other move and go to a different position, that's
If I go from this to this, then that's a different difficulty.
but that still could be a blank note.
Yep.
Okay.
So a blank node would let me go wherever I want.
I see. But there are different kinds of blank notes with different feet. I guess I'm confused as to what.
Okay, so let's go through them again. So
Is it kind of like it's like spreading? So really, when you have your source node, it's actually connecting to every possible move, and every possible move is connecting to your next. So it's kind of like a diamond shaped thing. Every possible-
not quite. So let's go through the nodes again, and then let's go through that. So the source move will be connected to some nodes, and then those nodes will be connected to other nodes, and it looks more like you have a big outgoing degree, then you have a big network, then a big incoming degree. It looks like a messed up sorting network. So nodes are constraints. This accepts any possible feed combination, right? So this accepts, crap. This,
Is the foot combination contained in that note, in that blank note?
no, the blank is a constraint.
Okay.
So if I have a node that looks like this, then if one of my feet is here and the other one's in the center, then that's fine. The constraint is met.
I see.
If one of my foot is up and the other one is down, then the constraint is met.
Okay. But the edge running into that blank note, depending on what foot, depending on how your feet land, is different difficulty. Is that right?
Yep.
Okay.
But when I compute the edge weight, I need to know where I'm landing exactly, not just what the node is, because the node might admit multiple positions.
I see.
So
Okay.
this guy admits all positions.
Okay.
This guy admits some positions, right? If these are LR, LR. If I have up, down, how many feet positions does it admit?
Just one.
Not quite.
Oh.
How many?
I mean, as an intermediate?
If it's up, down, then it's on the screen. My intermediates are all blank.
Oh, I thought you were saying starting with that node.
So up, down. If you see up, down on the screen, how many
Left, right, or
feet
you
position?
could have-
Yep. So if the screen says up, down, the only two ways I can do that is this or this, right? So two positions.
I see.
Well, I mean, but you could have an intermediate where you step first one, then back, and then.
But I don't care because I added these blank nodes and they take care of my intermediates for me.
But so we're saying where the feet land aren't part of the note.
Nope, they're just state. So they're a decision I'm making.
But so do we have then multiple? No, we don't, because they're not part of it.
So for each position here, I have multiple states according to, sorry, for each node position here.
Yeah.
So for every position in the screen thing, I have multiple feet positions that I could be in.
Right, right. But then are there multiple moves to get to those?
Yep.
Okay, so there's multiple moves connecting each.
Yeah, so there are multiple. So for example, if I want to get to LR up down here, I can go from LR up down in the blank, or I could have LR be like this and then transition. So I can have a lot of possible foot positions that I'm transitioning from in order to get here.
I see. But those aren't actually separate, like nodes on the graph.
They
Those
are.
just
They have to
those
be.
edges. Oh,
So these all have to be separate nodes because the edges are going to have separate weights, right? This edge is going to have one weight, this edge is going to have another weight.
okay, that's what I thought. But then we said there was only one blank. Can't a blank note be doesn't there have to be then multiple blank nodes for every foot thing if you're approaching a node from different? I guess I'm
So-
confused.
I'm not sure what you're asking. So we're going to have, if you want to care about centering, if you want to have intermediate moves, you need one blank node between every real node so that you're allowed to make one intermediate move between.
Right, I guess, but that's talking about this. That's talking about on the screen or on.
Yeah, that's the
not on
screen.
That's the screen.
Yep.
Okay. So that's not the graph, though. Here, are we talking about the screen or the graph?
Here we're talking about the graph.
Okay.
So 2 tells me that the screen is at node 2, whatever that happens to be,
Okay.
and my feet are in this position.
Okay.
Okay, so that's very important.
Clear.
Thanks for asking because that's very important. So a state has the node that I'm landing at, so where the screen is and where my feet are.
Okay.
Okay,
And state corresponds to the nodes.
a node. A node is a state.
Okay.
So a node is a state and the move goes between two states. This is how we represent all the graph problems.
Right. Right.
Okay.
But like each
So
one.
we need multiple blank. Well.
Yeah, so here I'm just drawing one example.
Oh,
Yeah.
okay.
Yeah, so for example, here I would need, sorry, oh, okay, I get your confusion now. So yeah, this would be one move, this would be another move, and
All for a single thing on the screen.
yep.
Okay.
But then
Okay, that
so
makes
the
sense.
next node would have a really large degree, right? Okay, so let's have.
Well, no, we have lots of different.
So this node has a huge out degree.
Yeah, but I'm saying the ones that all those intermediates connect to. Those
Yep.
are all intermediate. Yeah, so then they would connect to some node that have a really large
But-
integrity.
Yep.
But there's two of them after that, right? Because there would be two different.
At,
there's two
so
different
what's next?
functions
Next is
for it.
position. How did I number them? I guess. Crap. So 2 is,
Oh, wait.
no, it's not going to match that. So whatever we do is not going to match that. Say the next node 4 is just an up. So if 4 is just an up, actually say 4 is up down, and then I have 2 nodes for it, right?
Yeah.
One node LR.
Okay, okay. That makes sense.
So this is node 4, that happens to be up down, and then I have this. And every one of these connects to every one of these.
The next
Okay.
move is up, down. How can you know it's up, down, up? Oh, because you can switch the feet.
Yep.
Oh.
Yeah, so I wanted to ask you guys, how am I going to draw the edges, but you guys made me do it with questions. So suppose I'm at node NLR. What edges do I draw going out of it? So node N, left foot at some position, right foot at some position. What are my outgoing edges?
This is a node on the screen, or like a
In the
real
graph.
one or an intermediate one.
Doesn't matter. The node, so intermediate nodes have the node blank.
It's
So
just everything.
it doesn't matter. Yeah, we're looking at all of them at the same time.
Wait, so you're asking what an
So
yeah.
given this node,
Mhm.
who am I connecting it to? Let's draw the outgoing edges.
Oh.
So if you're solving this as a graph problem, you build a node, you draw the edges, you run some algorithm. So let's draw the edges.
I mean, if you're, I think it depends if you're an intermediate node or not.
Nope. So the node tells you what your constraints are, and that covers intermediate nodes. If your node is a blank, then, well, there's no constraints. If the node is not a blank, then there are constraints.
Oh, node. I thought that was referring to the node. No.
Node. So this is a node. Maybe n is not good. Let's use I instead then. If n is hard. So I is the position here. In this guy, right? Say, for example, I equals 1 here, I equals 2 here, I equals 3 here, so on and so forth. And that doesn't match this. So,
Node? We're talking about nodes.
yep.
Not
So one node, one node is represented by these 3 numbers, right? Each node has this tuple in it.
an I is the node.
Yep.
So I connects to I plus 1, and then all possibilities is all on
Okay, so this connects to I plus 1, and then all possible destinations, right?
I. Yeah.
So I'm going to say left, this is after the jump, so left after the jump and right after the jump. And this is for all possible left after the jump, right after the jump. And what's the weight? On this edge.
The weight is from
LR to
LR to LR.
LJ.
Yeah, but-
LR.
So you want to say from LR to LJ, RJ, but what?
Difficulty node?
Yeah, where's that?
Weird difficulty function?
Which is
D?
delta.
Oh.
So yeah, the weight is delta. Wait, I drew D. Delta of these 2 foot positions.
Okay.
Almost. If I want to minimize the difficulty,
Plus.
then this is right. If I want to maximize a score, then I would have to add a minus sign. But if we're minimizing the difficulty, this is exactly the weight because it maps to shortest path. Usually in dynamic programming, things are maximized.
Wait, why would we add a minus if it's?
So if we're maximizing something, we have to add a minus to the edge costs because, yeah, but this time we're minimizing something.
Oh, right.
I promised you that will maximize something all the time. Well, I guess I lied.
Okay,
If you don't want to maximize difficulty, that'd be bad.
No. You want to maximize show off. So if we have the entertainment thing, then that would be maximized, and then you'd have a minus.
Everything
Yep.
in
Okay, so we're almost good. Source nodes, destination nodes.
Well, I guess source would be the start in the middle. Right? Like you would start off with.
So how do we, what's a source? You want to start at the first node, right?
Yeah.
So, but in which position?
On the center, right? I mean, that's where you'd start. Or I guess you could
Could you
start
add
if you want, like position 1.
Could you add a source node going to a bunch of intermediate nodes and
Yeah.
then to the first node?
Yeah, so what I'm going to do is I'm going to say there is a node 0 that lets me choose how I'm going to start. Yep. So this is gonna have, so I'm gonna have a node 0 with all possible foot positions. And then this is gonna be connected to a source by edges of weight 0. So the intuition is that I get to choose my starting position, right? Starting position, I see the first node, I make a move. So I want to be able to choose the starting position. That's why I have all those nodes. And then make a move to touch the first node.
The starting position is also anything.
Yep. Because if the first node is here,
Yeah.
I don't necessarily want to start like this, because maybe this is harder than this. All right, what's the destination?
Last.
The last note.
Yeah.
Okay. So all the nodes that are at node n and have any position would be connected to a destination node using an edge of weight 0. Or I can consider them as destinations and then choose the destination that has the shortest path.
Oh, I see. You can take all the like the final destination is gonna be like 2 nodes, right? It's gonna be that last position and then.
Well, it might be more than 2 if the node is just a simple node, because that wouldn't
Oh.
constrain my feet too much. Okay, and last question. Dijkstra or Bellman-Ford?
Down forward, because you have negative edges, negative weights if you're gonna maximize.
Yeah.
Would it be Dijkstra?
So this is always going to be from 0 to 1. So I could possibly use Dijkstra. The answer is neither. The answer is
Yeah,
we're building a DAG.
yeah.
So
We don't use that.
DAG shortest path. Every time we have dynamic programming, DAG shortest path. Okay? Yeah. Come on, last question. You can't get away that easily. Okay, so who wants to play? That being said.
Okay. Can we turn down the timing difficulty?
Let me show you passing this after I return the microphone before I destroy it.